Hey, in this video, we're gonna look at how do we compare and order rational and irrational numbers. To get started, I wanna kind of go over the different types of numbers that we usually talk about. So we start here with what we would call rational numbers, and everything inside of this circle is a rational number. And those include all positive and negative whole numbers, fractions, decimals, but the decimals have to be able to be represented as a ratio of two numbers. So they have to be able to be represented as like a fraction, basically. So repeating decimals would work as rational numbers, and positive, negative fractions, decimals, things like that. Integers, however, gets rid of your fractions and your decimals, and it always has to be a whole number, but it can be 0 and it can be negative. So for example, 16 fourths, which is actually equivalent to 4, that would be an integer. And also you can have negative numbers here. However, then when we go in deeper, we get into a more specific type of number called whole numbers. Those include 0, but get rid of all the negatives. So again, we've lost the fractions, the decimals, we're down just to whole numbers. But again, they can be written as a fraction, like 13 over 1, and that just equals 13. So it has to basically, it can be a fraction, but the fraction has to be able to be reduced down to like a whole number, or 6.0 is a whole number. Then you have what is called natural numbers. Those are where you drop the 0 and you're just talking about positive whole numbers. So like 1, 2, 3, 4, and we're getting rid of this whole fractional representation. So you're just 1, 2, 3, 4, so on and so forth, kind of like you're counting numbers. But then say you have a number that can be represented as a decimal, and that decimal has no repeating pattern, it does not end. That's your irrational numbers. A couple examples would be like a square root of a non-perfect square. So like the square root of 2 is irrational. Pi is irrational. Or this decimal up here that I wrote, 0.024758326 dot dot dot. The dot 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 means it continues on with no repeating pattern. So again, the goal is to compare and order these rational and irrational numbers. What we can do is say we start with the square root of 74. I showed you a different strategy in the other video, but here's another way to do this. I can put it on a number line, and I know that you have the square root of 64 is 8, and the square root of 81 is 9, and 74 is between 8 and 9. 74 is between 64 and 81, so the square root of 74 is between 8 and 9. Now, since 74 is closer to 81 than it is to 8, you would guess that it's going to be bigger than 8.5. So what you can do is I start with 8.5. I actually square that. I do 8.5 squared, so 8.5 times 8.5. That equals 72.25. And then I go, so I know 74 is bigger than that. I do 8.6 times 8.6, and I get 73 and 96 hundredths. That's really, really close to 74. So that's a very close estimate. So I could say that the square root of 74 is approximately 8.6. It's close, but it's actually an irrational number that is going to, you can't actually write it down, but we would say it's approximately 8.6 for the purpose of comparing. So then say I have another irrational number, like the square root of 32, and this is 5.51326 dot dot dot. So there's no pattern, no repeating, continues on forever. I want to compare these two. So I start with 32. 32 is between 25 and 36. So the square root of 25 is going to be less than the square root of 32, less than the square root of 36. So square root of 25 is 5. Square root of 36 is 6. So the square root of 32 will be between 5 and 6. 32 is closer to 6. So I reasoned that I would start with 5.5 squared, which equals 30.25, still less than 32. So I did 5.6 squared. That's 31.36, still less than 32, so I keep going. 5.7 is 32.49, a little bit more than 32. So I know that 32, oops, I wrote that down wrong, is going to be between 5.6 and 5.7, or the square root of 32 will be between 5.6 and 5.7. So I've established that. And then 5.51326, for the purpose of this, I would say it's about 5.5. So I can say, okay, so 5.5 is less than 5.6, which means that this irrational number, 5.51, this is going to be less than the square root of 32. If I put it on a number line, here's 5.5, here's this number, there's 5.6, there's the square root of 32, there's 5.7. So 5.51326 dot 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 is less than the square root of 32. Then I now have this one where I want to take all of these numbers. This is the other situation. You'll have a whole list of numbers, both rational and irrational, and you want you to order them, comparing in order. So the first thing I have to do is kind of compare them. I start out by coming up with estimates or approximations. So I know pi is about 3.14, so pi squared would be 3.14 squared, which if you put this in a calculator, you get about 9.8596. So pi squared is about 9.8596. That's going to be good enough for this situation. 9.5 is exactly equal to 9.5. 9.8 is 9.8 or 9 and 8 tenths. 9 and 5 tenths repeating is going to equal 9 and 5, 5, 5, 5, dot, dot, dot. All right, and then the square root of 94 is going to be about 9.7. How do I know the square root of 94? It's about 9.7. I went back and did that same process I did on the first example. The square root of 94 is going to be between 81 and 100, so the square root of 81 is 9, square root of 100 is 10. 94 is closer to 100, so it's probably going to be greater than 9.5 or 9.5, 9 and 5 tenths. So I started that out. I did 9.5 squared, 9.5 squared. I got 90 and 25 hundredths. I went up higher. 9 and 6 tenths squared is 92 and 16 hundredths. And I went up higher because I'm on 94. 9 and 7 tenths squared is 94 and 9 hundredths. This is super close, so I just said it's about 9 and 7 tenths. So the square root of 94 is about 9 and 7 tenths. So once I had these kind of all converted into like decimal approximations, I was able to put them on a number line, and I did 9 and 5 tenths is where 9.5 is. That ended up being the lowest. 9 and 5 tenths repeating is between that and 9 and 6 tenths, so I put that there. Then came 9 and 7 tenths, which is about the square root of 94, so that came next. Then 9 and 8 tenths came next. And then after 9 and 8 tenths was the 9 and 8 and then some change. So this approximation is greater than 9 and 8 tenths. So then pi squared would be the greatest, 9.5 would be the least, and then the other numbers follow in suit. I listed them from least to greatest here. Just pay attention if you're asked a question that asks you to put them in a different order. So now you know how do we compare and order rational and irrational numbers.